Well, hello there, ladies and gentlemen. Here's what we're going to do in this quick video. We've got this rational function right here. It's kind of an ugly one. It's a complex fraction. We got a fraction inside of a fraction, a compound fraction right here. And what we have to do is we have to find the domain. Now, in case you forgot, the domain is the set of all possible inputs. So that means what values for x can you plug in? And there's kind of like two major limitations. So first of all, one is you can't have the square root of a negative, right? So if you end up having something like, well, let's say just, f of x equaled the square root of x, well, this would have to be, x would have to be greater than or equal to 0, because if it was less than 0, you'd end up with a negative number that's imaginary, and we can't graph that on our normal Cartesian coordinate plane, right? The other situation we have right here is that you cannot divide by 0. The reason you cannot divide by 0 is because division is literally asking a question about multiplication. So, if you had 8 divided by 2, the reason that this is 4 is because this is really saying 2 times what is equal to 8? And of course, 2 times 4. Let's see if we can get this to focus a little better. Oh man, 2 times 4 is of course 8. So that's okay, right? And this is okay. This says 8 times what number? 8 times what is equal to 0? So of course that's 0. 2 times what is equal to 8? That's what division means. So this right here means 0 times what number is equal to 5? 0 times what is 5? Well, since 0 times anything is 0, no answer to that. So if you end up with a situation like this, well, the domain, this x can be any number except 0. X cannot be 0. So our domain would be from negative infinity to 0, and then from 0 to positive infinity. So everything except for 0, right? And if it was, say, for example, 0, let's say it was x minus 8 instead, well, then x could not be 8, because if 8 was x 8 minus 8 is 0, and 3 divided by 0, once again, boom, no dice. So what you do in this situation, you take that denominator and you set it equal to 0 and you solve it, and that tells you what value that would make this equal to 0, and that's what number you cannot use. So in our situation right here, we have to take this denominator and we have to set it equal to 0 and solve it. And that will tell us what value x cannot be, because that's the value that would make this equal to 0. Now, right off the bat, before we even get to this part, check this out. First of all, I can tell you right now, x can't be 0. X cannot be 0 right off the bat, because this part alone would be undefined. You can't subtract something that's not a number. You can't subtract 1 from something that's not a number. So right off the bat, x cannot be 0. So let's put that over there just for now, right? So x can't be 0, because that would make this part undefined, and then you can't subtract 1 from it. Now what about the whole thing? So let's solve the whole thing. So we're going to add 1 to both sides, right? And then what we're going to do is, to solve this, we have to get x out of the denominator. So we're going to multiply both sides by x. And there you go. So x can't be 3, because if x is 3, then the denominator is 0. Look, 3 divided by 3 is 1. 1 minus 1 is 0. 5 divided by 0, no dice. Also, x can't be 0, because 3 divided by 0, no dice. That's not a number, so you can't subtract 1 from it, so the whole thing doesn't work. So there are 2 gaps in this function. Can't be 0, it can't be 3. So the way you write that is, so you have from negative infinity, which isn't a number, so it's a curved bracket, all the way up to 0, and then from any number from 0 to 3 works, and then from 3 to anything else you want works. But 0 you cannot use, so it's a curved bracket, and 3 you cannot use, so it's a curved parentheses, not a square bracket. So I hope this helped you guys. Hope it made some sense for you. It's kind of tricky. It's kind of sneaky how they put that in there like that, so that if you just solved it, you only get one of the forbidden values, if you will. But you also have to look and see that x can't be 0 either. So I hope this was helpful, and hope you're having a good day.